It's time to use what we have learned in vector resolution to solve two-dimensional problems. Let's go through the vector resolution that we have learned, and we're going to use this again and again in all the problems. So before I do that, let me just point out that there are two or maybe three aspects of problem solving that you will see again and again. The first is, what is the free body diagram, or we've been calling it FBD, and you know that we need this to apply Newton's second law, which says force is equal to mass into acceleration, and this time we highlight that they are vectors. So this aspect you know. Now this is the interesting second part of the problem, which is, what is the coordinate system of the observer? Now this doesn't a priori strike you as a important aspect of the problem solving, but it is going to be often very key. The choice of the coordinate system is going to be key to the solution of the problem. I would like to remember my teacher's example, which I thought was very striking. So he had once pointed out that when we study the planetary motions around the sun, and when the observation point was Earth, the observations carried out from the Earth and tracking the planets, tracking the path of the planets with the Earth as the origin, gave very confusing trajectories, and it was difficult to make sense out of it. But there was one great idea to shift the origin to the sun, or shift the coordinate system to the sun, and suddenly we have much more simpler orbits to analyze, that is the ellipse. So this is a striking example of how changing the coordinate system from the Earth to the sun suddenly simplifies the problem. So I can confidently say that the choice of the coordinate system, while it will not solve the problem, may play a very key role in the simplification of the problem, and we'll return